So welcome back to the last lesson in fundamental quantities and also units, whereby we'll be finishing with the dimensions and also dimension analysis. In our physical class, we defined what a dimension is. We said it's a type of quantity which we are dealing with, independent of its units or value. For example, if you take 100 centimeter, you have a unit of centimeter and a value of 100. But in terms of dimension, we say this is a dimension of length. And also if you look at 1 meter, you have a value of 1, and also you have a unit of meter. But all these are dimensions of length. If you look at 2 miles, all this is also measuring what? Length. So regardless of what the unit is or what the value is, if the dimensions are measuring a particular quantity, then it becomes the dimension of that particular quantity. If you are looking at, let's say, time, and you have 20 milliseconds, then another one is saying 1 hour, all these are dimensions of time. They are measuring a particular quantity, which is time. So regardless of what the units are or what the value is, you look at a particular kind of dimension. So only if you take the value of 100 is not a physical quantity, because they said for physical quantity to be called a physical quantity, then it should have both a magnitude and also a direction. A magnitude and also a value, which is a magnitude and also a unit. So if you just say 100, we said in physics doesn't mean anything. Also in terms of dimensions, 100, just a value, any constant, is called dimensionless. So when you are dealing with the dimension analysis, you don't take into consideration the value of your physical quantity. What you consider only is the dimension which you are dealing with. So a dimension has a lot of importances. Firstly, it helps you to check the correctness of an equation. You can derive the relationship between a physical quantity and also a physical phenomenon. You can also change a unit from one form to another using dimension analysis. Now, in solving the dimensions as rules, number one, you shouldn't regard the values. If you have a particular kind of scenario where you are given values, then disregard the values. If you are given the units should just aid you to find the dimension of that particular kind of quantity, because the unit will show you the physical quantity which you are dealing with. In physics, we have basically these 3 most common dimensions which we'll be looking at. We have the dimension of mass, which is represented in square brackets. So the dimension of mass is represented in a square bracket as m. So disregard these brackets, they should be square brackets. So the dimension of mass is given in square bracket of m. The dimension of length is given in square bracket of L, and the dimension of t, time, is given in square bracket of t. So regardless of whether mass is measured in grams or is measured in kgs or is measured in milligrams, the dimension of that mass will always be m. Regardless of whether you are dealing with a kilometer, you are dealing with a meter, you are dealing with a decimeter or a centimeter, the dimension of this particular kind of physical quantity, it will always be L, which is length. And regardless of whether you are dealing with the time in seconds, in hours, in milliseconds, always the dimensions of time will be capital letter T. So these are the 3 basic dimensions which we'll be using in physics. Now, number one, we are saying the dimension analysis helps us to check the correctness of an equation. And we are saying basically this is based on homogeneity principle, which says that the dimensions in the left of an equation should be equal to the dimensions to the right side of an equation. Now let's look at a scenario which we are saying it helps us to check the correctness of an equation.